When solving word problems, it helps for us to first understand a little bit of vocabulary. So the angle of elevation is, instead of looking straight forward, if I have to look up at something, this is the angle of elevation. The angle of depression, instead of looking straight forward, if I have to look down at something, that is my angle of depression. The angle of elevation from the person looking up to the kite is the same number as the angle of depression from the kite looking down to the person. Again, the angle of depression from the cloud looking down at the house is going to give me the same number as anyone standing at the house who looks up at the cloud for their angle of elevation. Generally, when we do word problems, I draw in this bottom triangle with the base even to the bottom of the piece of paper, which means I would have a triangle drawn here for you. So be aware that the angle of depression is generally on the outside of a normal triangle, or it's on the inside of an inverted upside down triangle where the base is on the top. It gets a little bit confusing, but luckily the angle of elevation is the same number as the angle of depression. So anytime you see the words angle of elevation or angle of depression, just stick the angle in the bottom corner of your triangle and you should have it set up correctly. Yes, this is technically the angle of elevation, but it will give you the same answer as if we had solved for the angle of depression. Let's do some examples to see if it clarifies anything. To solve these examples, we are solving triangles. Luckily, we are only solving for one specific piece instead of all three sides and all three angles. And a reminder, if you're solving a right triangle, label your sides opposite, adjacent, hypotenuse. Based on what we're given, what we're looking for, and SOHCAHTOA, you can set up a fraction. Cross multiply if you're looking for a side, or use inverses on your calculator if you're looking for an angle. And finally, type your answer into your calculator to get a decimal answer. So example 1. A bridge is 750 feet tall. The angle of elevation from a boat in the harbor to the top of the bridge is 50 degrees. How far is the boat from the foot of the bridge? So based on this picture, hopefully you can tell that this is my bridge, here's the water, and here's my boat. So the bridge is 750 feet tall, right here. The angle of elevation from the boat in the harbor. So instead of looking straight forward, if the boat looks up to the top of the bridge, there's an angle of 50 degrees. That's my angle of elevation. The water should meet the bridge at a 90-degree angle. And we are looking for how far the boat is from the foot of the bridge. We're looking for this piece here. Label your triangle. So from this 50-degree angle, across from the 50 is the 750, which is my opposite side. Beside my 50 is the X, which is my adjacent side. And I don't really care about the hypotenuse. It's not giving me any information, and I'm not solving for it, so I'm not even going to label it. SOHCAHTOA. Which of these fractions deals with opposite and adjacent? Set up your tangent fraction. Solve for x. I write tangent over 1 to make it super clear, and then cross multiply. You're going to have to divide your tangent of 50 over to the other side to get x by itself. And then make sure your calculator is in degree mode and type this in. Make sure you include units with your answer. Always include units for word problems. Example 2, you're on top of a 30-meter tower. You spot a store that is 20 meters from the base of the tower. What is the angle of depression? So let's label our triangle. Assuming this isn't the Leaning Tower of Pisa, the street should hit the tower at a 90-degree angle. Our tower is 30 meters tall, and the store is 20 meters from the base of the tower. We are looking for the angle of depression. Technically, angle of depression is, instead of looking straight forward, I'm looking down. So technically, I'm looking for this angle, which means if I want to find the angle of depression, I can't just draw a new triangle and then based on rectangle rules, if this is 20, that's 20, if this is 30, this is 30. And so I can just solve this using this red triangle. Or I can use the fact that the angle of depression is equal to the angle of elevation and just draw my angle in the bottom corner and now solve this pencil triangle. Either way you do it, 30 is going to be the opposite angle and 20 is going to be my adjacent angle. Opposite and adjacent. Again, this is a tangent problem. I swear they're not all tangent problems. That just happens to be these two examples. But you'll set up tangent. Across from theta, either I'm using the gray or the red, it's 30. And beside theta, either I'm using the gray or the red, it's 20. Whenever you're looking for an angle, you use inverses on your calculator. So that is second tan 30 divided by 20. So theta equals, I can use correct notation here. You don't have to. Theta equals 56.31 degrees. Make sure you include units, which is degrees here, because this is a word problem. Okay, our last example is not going to be a tangent example, and it's going to be a double triangle. So it seems like it's going to be a lot harder, but actually, if you understood the last two examples, this one is just like having twice the work, but not harder work. So let's just do this example. Philippe sees two hot air balloons. The lower one is 700 meters away at an angle of 38 degrees from the vertical. The higher one is 1,050 meters away at an angle of 26 degrees from the vertical. How much higher is the balloon on the left? So we're trying to figure out what this distance is right here. What we want to do whenever we see a lot of these double word problems is you need to solve for the same distance in each triangle you see, and then you usually end up either adding the two distances together or subtracting the two distances. So in this case, I'm going to solve for this height right here out of this big red triangle. I'm going to solve for this height right here in this blue triangle, and then I'll subtract the blue height from the red height. Okay, so let's deal with the red triangle first, because I happen to have a red pen. Here's my angle. So here's my 90 degrees. That means 1050 is my hypotenuse. Across from 26 is the opposite. I don't care about that side. Beside 26 is my adjacent. That's the height here. And now everything on the left-hand side is all calculator buttons, so type that into your calculator. Make sure you're in degree mode, and you'll see that x is 943.734. You want to include extra decimals on all these intermediate steps, and then at the very end, I will round to just 2 decimal places. Okay, so that's the height of my red triangle. Let's do the same thing with the blue triangle to figure out what its height is. Round to 3 decimal places right now because my final answer I like to round to 2 decimal places, so all these intermediate steps include extra decimals. So now how much taller is this from this? Just subtract. Make sure you include units with this because it's a word problem, and you should have 392.13 meters. Reminder, when you do these double triangle word problems, usually you need to solve for the same side in each triangle, and then you usually end up either adding or subtracting them together. Pay attention to the diagram, it should help you.